Welcome to another edition of Math for No Reason. In this edition, we are looking at this problem which asks us to find all functions f whose domain and codomain are both real numbers and which satisfy the following properties: that f of x plus y is greater than or equal to fx into fy for all real numbers xy, and fx is greater than equal to 1 plus x for all real numbers x. So we will proceed to solve this problem in multiple steps. So first we observe that f of 0 plus 0 is greater than equal to f0 into f0, which is f square 0. So f of 0 is greater than or equal to f square 0, that is from part A, and from part B we see that f0 is greater than or equal to 1. Now the only real number which is greater than or equal to 1 and which satisfies this condition is 1 itself. So let's prove that. So since f0 is greater than or equal to 1 and hence non-zero, so therefore we can cancel f0 from both sides and get 1 greater than equal to f0. Considering both of these, star and star star, we can conclude f0 is equal to 1. That's the first important conclusion we have, that f0 is equal to 1. Next, we look at f of 2x. By part A, f of 2x is greater than equal to fx into fx, which is f square x, and that is greater than equal to 0. So for any real number x, f2x is greater than equal to 0, but x is arbitrary. So from here you can conclude that f of t is greater than equal to 0 for all t belonging to R. So essentially we are dealing with a non-negative function f which satisfies the condition that f0 is equal to 1. These are important results that will be useful for us. Now we note that while we are given that f of x plus y is greater than equal to fx into fy, we can use this to conclude that, say, f of x1 plus x2 plus x3, where x1, x2, x3 are three real numbers, is greater than equal to f x1 plus x2 into f of x3 by part A, and that is greater than equal to f of x1, f of x2 into f of x. And by similar way, using induction, we can conclude f of x1 plus x2 plus xn is greater than equal to f of x1 into f of x2, etc., f of xn. And this is true for all natural numbers. So we have got three very interesting results till now. One is f0 is equal to 1, the second is f is non-negative, and third is that f of x1 plus x2 plus xn is greater than equal to fx1 into fx2 into fx. So let's use this further. Now we can write f of x as f of x by n plus x by n plus x by n, and this is n times, and from delta we get that this is fx by n whole raised to the power n. So fx is greater than equal to f of x by n to the power n, and f of x by n is greater than equal to 1 plus x by n by part B. So this is greater than equal to 1 plus x by n to the power n. So fx is greater than equal to 1 plus x by n to the power n for all natural numbers n. So taking limit as n goes to infinity, we get fx is greater than equal to e power x. Recall that limit n goes to infinity, 1 plus x by n to the power n is equal to e power x. So fx is greater than equal to e power x. So let's proceed with this. Now, f of 0, you can write it as x plus minus x, and that is greater than equal to fx, and we already know that f of 0 is 1. So, from here we get 1 is greater than equal to fx into f of minus x. Since fx is greater than equal to e power x and f of minus x is greater than equal to e power minus x, and these are all non-negative quantities, so this is greater than equal to e power x into e power minus x, and e power x into e power minus x is equal to 1. So this gives us that fx into f of minus x is equal to 1. So f of minus x is 1 by f of x. Now since fx is greater than equal to e power x, so 1 by fx is less than equal to e power minus x, 1 by e power x, which is e power minus x. And this tells us f of minus x is less than equal to e power minus x. But we know that f of minus x is greater than equal to e power minus. So from these two we can conclude that f of minus x is e power minus x, and since f of minus x is 1 by fx, so this would give us fx is equal to e power x. So we have been able to determine fx exactly as e power x. Thus, the only function that satisfies both these conditions is the function fx is equal to e power x. Thank you.